Oh, that sounds like someone knocking now. What the heck? I'm hearing things. Right, so I've got the new delay line hooked up, and elastic bands holding it on there. Yeah, holding everything else on there as well. Them little wires were a bit fiddly, so I stuck some thicker wires into some header posts which I plugged in. That's what my headers are on the circuit board. So I put thicker wire in there and I soldered it onto my thin wires because I got sick of twisting these thin wires. Also, the thin wires would eventually snap and break, so I thought, well, I might as well solder them on. Then all I have to do is unplug these wires out of these sockets and just pull them out, and then when I take the board off I can make changes and improvements. But yeah, if you remember the previous video, I was getting about 190, 210, about 210 milliamps output to supercapacitors when they were flat, which is what they are at the moment, 3.17. So they're basically discharged at to 3.17 volts. No current at the moment because it's not running. I've got the same batteries as I was using previously. They've been charged up. So what is it going to work? The question is, does it work better than it did? Well, my attenuation isn't as good on the trimmer pot, so I might actually do away with a 100 ohm one or something, or bypass one of the legs. We'll see later. But because I've got a bigger capacitor on the input, my LEDs don't light up, but that's not a problem. I mean, I can soon sort that out. But the main thing is, let's connect the power leads onto these batteries. Right, negative, positive. Right, LEDs on current limit, yellow LED at the moment. That should go out pretty soon. But look at the current output. And look at the supercapacitors charging up. That's a bit faster than before, isn't it? Yeah, it's working a lot better, and I haven't got the RPM yet. I mean, my RPM's still pretty low. It's picking up speed as it is. Let's take the load off for a minute. Let me just take the load off a second. Let's let it pick up speed. Right. Right, I've got it up to speed. Let's put the load back on while I connect this. Wow, look at that. You see that was at 300 milliamps for a minute. Now if I can get rid of the rest of the drag, which I'm still tuning at the moment, and does my delay line work? Yes, it does work. It works pretty well, but there's still room for more improvement. Let's look at the waveform. The blue trace is the delay line pulse, and the yellow trace is the main output current pulse. We can see the voltages there. Right. 240, well, 250 milliamps. It's going up still, look. Well, it was. I think that's an improvement, don't you? I think that's an improvement. My current limited LED is still lit though. The yellow LED is still lit, so we are a bit restricted on the voltage. When it gets to 13.8 volts, that's usually when it settles down. But at the moment, yeah. And what does my tapping switch do? Right. Now I'm going to move this 3D printed, custom designed tap switch, I'm going to turn it, and when we turn it, I'm going to show you what happens on the scope. Right, the blue trace, watch the blue trace. Ah, it's hard to get a hold of this. Right, watch the blue trace as I turn it back again. Oops. It jumps. Well, it's a homemade switch, remember, but it just worked. But there's a bit of a dirty contact on it. Trying to get it settled on that one. Well, that's the top one. Right, there we are. That one. So when I turn this switch, it attenuates, but yeah, my contacts aren't perfect. I need to adjust. I probably need to put a bit more solder blobs on my contacts. But yeah, it's charging up really fast, look. So what's the next phase? Well, I need to change that capacitor. Oh yeah. I need to change that 47 microfarad and put a 22 microfarad in, because I think it's a little bit too big. Because not enough juice is getting through to the delay line for the exit coil. So if I change the 47 and put a 22 in, and if you look at the diagram, the 47, I've marked it there. Oh, come on, focus. The 47's there, and I'm going to change it and put a 22 in, so that this is basically a cross in series with the generator coil. The generator coil is in series with all this, so this basically, whatever power goes in series on the load is shunted through. So if we put a big capacitor there, more power goes to the current output, right? So we get more output current, but less power is able to be charged on the capacitor. So I mean, we end up with a low voltage on the capacitor. So not enough voltage means less to go through the delay line to our triac, which drives the exit coil. So I have to get a balance, a happy medium. I'm also thinking about changing this variable resistor and basically soldering these two legs together so that we have a direct attenuation that way. Because at the moment it's just basically moving that capacitor between the input and the supply to the exit coil. So I'm going to change that resistor, the variable resistor, and join these two legs together. And I'm going to put 22 microfarad in there. The LEDs should then come on, because at the moment they're basically being bypassed because most of the current's going through here and not much is going through the LEDs. But the LEDs are useful because they give me an idea exactly what is happening at this end when I attenuate the trigger, because when the LEDs are lit, they'll get brighter when more current is going through the triac to the exit coil, basically. But because they're not showing up right now, it's hard to see what's going on. But it has made some interesting noises occasionally. It makes this really strange ringing sound. I mean, it sounds like a squeal or something. Look how fast that supercapacitor is charged. It's already at 10 volts. We're still at 191 milliamps as well. That's a hell of an improvement. I'm at 5,000 RPM already. 5,200 RPM. So, is it better than before? Yes, it is better than before, because we're already at 10 volts and we're still delivering 187 milliamps at 10 volts. I mean, yeah, that's pretty good. So yeah, just a little update. Oh, I'm shaking again. I can't keep my hand still. So I'm basically going to stop shaking. I'm going to turn it off for a while because I'm going to make some changes. And in a few hours time, or when maybe soon, I don't know, I'll do another video. Anyway, I'll see. I might sort that switch out a bit as well. I don't know yet. Well, it doesn't seem to make much difference. It's on the maximum setting really. It's as in that I'm using the full choke assembly for the maximum delay when it's at that position. When it's on that position there, basically I'm connected between this choke here. I'm basically connected between this choke here and directly across there to this one here. So these two are basically bridged directly over. When the switch is in the next position, this connection here is connected to that capacitor and choke there. And when it's in the next position, this connection here is connected to that choke there. And if you're asking why there isn't a switch on the circuit diagram, it's because it's a custom made switch and I didn't have a switch in the PCB software that I could have used that was suitable really. I'll have to try and dig a bit deeper and see if I can find a switch, but there might be one somewhere. But then you get the imprint. You end up with a component that you've got to print on the circuit board, and I didn't want that because my switch is not the same. It's custom. It's a round rotary PCB switch, and I don't want the clutter, so I just took a header on there, which is basically that thing there, that little socket, which is not used because it just simplified it. I mean, I could still put the switch on the circuit board without having all the extra clutter or all these extra switches which I wouldn't have needed, you know. So anyway, look at that, and we're at 12 volts already, and our current limit has gone out. LED, the yellow LED, it's below 800 milliamps now. So we're now voltage control. We're now at the voltage control limit, 13.8 volts, and we're still pushing out more current. And we can see how my little pulse is on there as well. Right, so anyway, that's it for now.